right, let's do the first 5 homework problems. Remember, you have conversions. A nanometer is 10 to the negative 9 meters, or you can say 10 to the 9 meters. Nanometers is a meter. Throughout this unit, you also need to remember that 1 eV is 1.6 times 10 to the negative 19 joules. Another part of the homework is the mass energy equivalence, or we'll call this the rest mass. Energy is mc squared, where E is energy measured in joules. M is mass, and make sure it's in kilograms. C is the speed of light in meters per second, and C is always 3 times 10 to the 8th meters per second. All right, let's convert to nanometers. Now, how do you want to do these? Let's see. I know 10 to the 9th nanometers is 1 meter equals. Goodness, pen's not working. So 7, 8, 9 times 10 to the negative 7 meters is how many nanometers? Well, let me do this. I'm going to multiply by 1 meter in the denominator, so that's going to cancel, is 10 to the 9th nanometers. So the meters are going to cancel. So this is 789 times 10 to the negative 7 plus 9. Because remember, when you have the same base and you have different powers, you add the exponents. So this is 789 times 10 to the 9 minus 7 is 2. So this is 7, 8, 9, and then I'm going to add 2 zeros. All right, let me switch pen colors here because that one's bugging me. What if I want to convert this one to nanometers? This is 789 times 10 to the negative 8th meters times 1 meter is 10 to the 9th nanometers. Meters are going to cancel, so this is 789 times 10. Now we add our exponents, negative 8 plus 9, so this becomes plus 1. So this will be 789 times 10 to the 1, or 7890 nanometers. I need a nanometer up here, don't I? All right, now what about 789 times 10 to the negative 9 meters? 2 nanometers, this is 1 meter, is 10 to the 9 nanometers. So this is 789 times 10 to the negative 9 plus 9. Negative 9 plus 9 is 0, so 10 to the 0 is just 1. So this is 789 nanometers. Now, 789 times 10 to the negative 10 meters times 1 meter is 10 to the 9 nanometers. Meters cancels. So this is 789 times 10 to the negative 10 plus 9. So this is 789 times 10. Now we add these. This is negative 1. So I'm going to move the decimal over 1 point. So this is 78.9 nanometers. All right, you're kind of getting the pattern here, aren't you? 789 times 10 to the negative 11 meters times 1 meter is 10 to the 9th nanometers. All right, so this is 789 times 10 to the negative 11 plus 9. So this is 789 times 10. Negative 11 plus 9 is negative 2. So that means we're going to move the decimal over twice. So this is 7.89 nanometers. All right, the last one, 789 times 10 to the negative 12 meters. And I'm going to convert this to nanometers. 1 meter is 10 to the 9th nanometers. So this is 789 times 10. Let's see, I've got negative 12 plus 9. So this is 789 times 10 to the negative 3. Now, Now let's move this back. 1, 2, 3. 0.789 nanometers. You could have left it 7.89 times 10 to the negative 1. I'm fine with that. Now we're going to convert to meters. All right. 0.125 nanometers. And I know, how do you want to do this? Let's do 10 to the 9 nanometers is 1 meter. So this is 0.125 times 10 to the negative 9 meters. Let's put this in standard form. So we're going to move this over 1. So this is 1.25. Since I moved it this way, it's times 10 to the negative 10 meters. All right. Let's try 1.25 nanometers times, let's do it this way. 1 nanometer is 10 to the negative 9 meters. This becomes quite obvious. This is 1.25 times 10 to the negative 9 meters. All right, 12.5 nanometers times 1 nanometer is 10 to the negative 9 meters. I like it this way, so let's do it this way. So this is 12.5 times 10 to the negative 9, because the nanometers cancel there. Meters. Let's put this in standard form. This is 1.25. We're going to move this to the left, so it's times 10 to the negative 8 meters. And finally, 125 nanometers. I'm going to convert this. 1 nanometer is 10 to the negative 9 meters. So this is 125 times 10 to the negative 9 meters. Now I want to move this back 1, 2. So this is 1.25 times 10. Now I moved it to the left. So this is going to be 9 minus 9, 8, 7. Minus 7 meters. Now calculate the energy when 2.3 kilograms of uranium-235 is converted to energy in a fission. All right, so the mass is 2.3 kilograms. The other given is C is 3 times 10 to the 8th meters per second. So I'm looking for the energy. I know the energy is mc squared. So it's 2.3 kilograms times 3 times 10 to the 8th meters per second squared. Go on and do the square first. All right. 3 times 10 to the 8th squared gives you 9 times 10 to the 16th. So this is 2.3 times 9 times 10 to the 16. All right, so 9 to the 16 times 2.3 is 2.07 times 10 to the 17th joules. Calculate the amount of energy when 15 kilograms of plutonium is converted to energy. All right, so same problem. M is 15 kilograms. C is 3 times 10 to the 8th meters per second. So I'm looking for the energy. E equals mc squared. So this is 15 times 3 times 10 to the 8th squared. Go on and do the square first. This is 15 times 9 times 10 to the 16th. 15 times 9 to the 16th is 1.35. Well, hold on. Let's see. I'm getting a different number than that. All right, I'm getting 1.35 times 10 to the 18th. Happens. All right. Nuclear bomb releases 63 times 10 to the 12 joules of energy. Calculate the mass. Okay. So the energy, oh goodness, my pen's messing up, is 63 times 10 to the 12 joules. C is 3 times 10 to the 8th. So I want the mass. I know E equals mc squared. So the mass is E divided by c squared. So it is 63 times 10 to the 12 joules divided by 3 times 10 to the 8th squared. Okay, so this is 63 times 10 to the 12th. Go on and divide by 3 times 10 to the 8th. And go on and square that. So it's 9 times 10 to the 16th. Now do your division. All right, 63 times 10 to the 12th divided by 9 times 10 to the 16th gives me 7 times 10 to the negative 4 kilograms. Now, if we want to convert this answer is fine. 7 times 10 to the negative 4 kilograms. I know 1 kilogram is 1,000 grams. So this is, let's cancel, 0.7 grams. This answer right here is fine.